Hi guys, this is H here. So we are going to do a problem where we're going to use the steps for drawing a force diagram, but I wanted to first review a couple things before we get started. So when we're drawing a force diagram, remember what a force diagram is. It's a model or an illustration of all the forces acting on an object. And so when we do force diagrams, we usually are going to be dealing with contact force, and then we'll use non-contact force, which is gravity. We won't use electrical force or we won't use magnetic force, but we'll use normal force or the object agent on object, a push or a pull, tension, friction, and drag. So those are our common forces that we use when we're drawing our force diagram. So remember, a force diagram is that model. So if you notice this image down here, this is the force diagram of a car driving on the expressway. And so notice we have vectors representing all the forces acting on the cars because a force is a vector because it has both direction and magnitude. And so that's why force diagrams and vectors are ideal for this situation. So let's look at an example here. So let's see, I have a bike and I am cruising along at a constant rate. How would I draw a force diagram? So there's six simple steps in drawing a force diagram. So sometimes you'll see a force diagram where we have a dot and sometimes we have a box representing the object. Then we have to determine all the forces that are present acting on the object, and so in this case, it's the bike. Then we need to determine the direction in which each force is acting and add the arrows for each force in the correct direction. And then we label the arrows and then indicate if the object, what kind of motion the object has. So let's go ahead and break this down for a biker cruising at a constant rate. And so we're specifically going to be doing a force diagram for the bike. So the first thing we need to do is draw the box. And so the box is going to represent the bike. And so what forces do we have acting on the bike? So we have an applied force from the biker on the pedal. We have the force of friction because it's moving along the road. And then we have the road pushing up on the bike. And then we have gravity pushing down on the bike. And so that's we're going to, in this scenario, negate drag and air just to make this a little easier for us. So I have the force of gravity. And so unless we are on in space, we will always have the force of gravity pushing down on our object. So the force of G, or you can put the force of Earth. Either is fine on how you label it, whether you use the object on agent reaction or symbolization, or we do this. So what else do we have? We have an upward force. This upward force is the normal force or the ground pushing on the bike. So we have ground on bike, and the ground is pushing up. Okay, and so that is, these two are balanced and working in opposite directions. So we also have here the applied force, and I'm sorry, I'm running out of space. So this is the applied force or the push on the bike that the biker is making. And then and this would be if the bike is moving in a rightward direction. So if the bike was moving left, then we would change our arrows around or our vectors around. And so then on this side, I draw another arrow and I try and make them to be almost the same. And sometimes it's kind of hard, but we can eyeball that. They're about the same length. And why do they need to be the same length? Because this person in the bike is moving at a constant. And so the force of friction is equal to the force that the biker is applying, because we're at a constant velocity. So that means the object is moving at a constant velocity. And I'm just going to put CV because it's kind of hard to draw with my pen here. So here's an example of how to draw a force diagram for a bike, and you're going to be practicing these over the next couple of days. Remember, if you have any questions, you're reaching out to me, and if you're struggling to make the force diagrams, you can always come back and rewatch this video. Hope this helped in drawing your force diagram. Bye, guys.